So, welcome back. We are continuing with our lab work on spatial information science, and I am Shahab Fazil from Department of Geography at Aligarh Muslim University. If you recall, with with our previous lab work, now I am sure that you are familiar with different QGIS menus, their location and their utility and purpose. All of them you might be now familiar with. As I have said, yes, um, on my previous discussion with you, that you should explore the QGIS so that you can have a better idea about the different operations tools which are used in QGIS. You should be familiarize it with yourself. Although we would be pointing out some methods as to how you can operate it effectively, efficiently, but still I am uh, giving you a lot more emphasis on exploring it yourself. That way you would learn more. So my argument is that you should have a better idea about QGIS graphic user interface, and I'm sure that you would be familiar with it. So now we are starting with QGIS for spatial representation. So how we bring any spatial information in digital format? We discussed this at length during the theoretical part, conceptual part of our discussion on what is the importance of spatial information and how we can bring in any information into digital format. So that way, in this specific discussion, we would be looking into as to how in a lab, in the system, practically we can bring the map into the digital format and use it for further analysis. So to bringing into the digital format, we require any map. So any scanned map can be in digital format. Although, as you recall, we have said that these scanned map, they might be digital but not spatial. Why? Because they do not have the coordinates. Even if it is being displayed, it is not coordinated with the system to read the spatial location. So you need to assign the spatial location into the map in the system. So how it can be transformed or what we need to do, that's an interesting aspect which we would be doing today. In this particular session, we would be georeferencing our map. So in this lab exercise, we would initiate of our journey to learning spatial information analysis by bringing a non-spatial scan map image to a spatial map. So in this exercise is about georeferencing a topo sheet or an India map or a state map or an image using graticule, intersections which are known to us. So as you are aware, I am using the term georeferencing. So if you recall, I would say that georeferencing is a process of establishing a relationship between the image or map coordinate system to the real world spatial coordinate system. That is, in simple words, aligning the ground coordinates with the map coordinates, with the map to which georeferencing is being made. I mean, assigning the known coordinates to the known region. So if you look here into the image which is being displayed now. So in this exercise, we will be using an image of India. We will begin with a map of India, of which the coordinates are known to us, and we want to georeference it. So this is a scan map. As I am saying, that scan map is in digital format. But you see, one more thing, if you recall, we have highlighted during our discussion earlier that these digital format maps which are achieved through scanning of map, they are in raster format. You recall we discussed about raster format and vector format. and in subsequent lab exercises we would be digitizing. So when we would be digitizing, it will be converting the raster image into vector format. So when we digitize, it becomes vector, which it becomes the information, the point, line, area, entity into vector format. But the scanned image are in raster format. So here we are georeferencing, and we find that this image, this map of India which we would be georeferencing, it is in raster format. And you can check first it by referring to its property about its format. So that's another basic knowledge about it, that how you can know to the format of the map which you are using. So that if it is in geospatial format, in GIS format, we refer to the metadata. But here, since it's an image format, it might be JPEG or TIFF or BMP format. So there you can check with its property, where you can see that it is in raster format. Or rather I should go back to this. So for georeferencing, in this exercise we will use an image of India with coordinates. So you see what we will do, if you recall, yesterday in our previous discussion we discussed about what are the different menus in the menu bar. So within the menu bars we said that there is vector, there is raster. So as we know that it is a raster image, so we would be clicking the raster menu from the menu bar, and when you pull down this raster menu bar, there is georeferencer, and if you click georeferencer, this kind of image would come onto your screen. So you have to click onto georeferencer here, as you can see here. Then the next step would be, that way this kind of screen would be appearing on map view would be appearing on the screen. It will have two components. One is the upper part, and the lower part is it is divided by with one line. One separation is there between the main workspace and GCP tables. The upper part is known as the main workspace, where the map which we are which we want to georeference, that will appear. And when we start georeferencing, we would be adding coordinates to the map. The coordinates which we would be inserting into the maps, that would come into the GCP table. So this is what we would be performing. So then we would be, when we would draw the map or topo sheet or whatever map is there, it will appear like this. And from here, the next step would be like this. Here it's another interesting part, that we need to select the coordinates reference system also, which is known as the CRS. Again, I would say that we have discussed at length in our previous discussions about the importance of coordinate reference system. So here we would be selecting WGS84. There can be many other options also, but for India, it is a standard georeferencing system, coordinate reference system, which we would be adopting. WGS84 we would select, and this can be, you have to scroll it down here in this particular section and identify WGS84. And and you would find that there are hundreds of options which would be available. So you need to look into as to specifically the WGS84 only. But if you want, you can select here the CRS, the coordinate reference system, in the bottom where selected CRS. If you will type here WGS84, it will come over here, and then you have to select and click on OK. So that's another important step which you need to recall. The next would be this way it will come. Then you know that if you will enlarge it, you would find that there are certain coordinates. You have to select few coordinates. A minimum of 4 is required. Now this is again an interesting aspect of georeferencing. Ideally we should add as many as we can, but all of them should be accurate. When we are georeferencing. Sometimes if we do not use appropriate number of coordinates, then the georeferencing will fetch some kind of error. We will discuss it later, but right now if I can say that the map would be loaded over here, we have to add the ground control point or the coordinates of this map which we are georeferencing. The coordinates are known to us. We would add the GCPs or ground control point. So here in a map you have to zoom in and you have to click here, add GCP, and when you click on any of these GCPs, it will appear here, just a moment, like this. So here you have to include the x-axis or latitude and longitude details over here, and you have to click OK. So this way you can add the GCP. So as you can see very clearly, I have highlighted that for adding a GCP, you have to click on this which was appearing in the menu bar, add point button, go, and then you will get this sign of plus. You just have to click over here, and this way you would be adding the ground control point. And as soon as when you fill the ground the digits of latitude and longitude and click OK, the one GCP would be recorded. Now here there is one more important point which I would like to for you to be a little careful about it. Yes. So here I would say that now you need to understand that the coordinates, they come in different format. For example, if it's a map which has latitude, degree, minutes, there is possibility. Sometimes it's only about the latitude, longitude figure, but it might be in the decimals also. This latitude and longitudes might be in decimals also. For example, if you see here, it is 74 degree 14 minutes 10 seconds. So this requires, you do not have those symbols here. So you would say that this is about the longitude. So 74 degree. So 70, you would insert 74, then give a space. Then the minutes are 14. So 14, then again you give the space and then 10. That way you have to record. And if it is only about latitude or longitude with only one digit, say 74, then you do not have to do anything else. You put the digit as 74 and 42. That's it. But if you have the decimal degree also, decimal digits also for latitude and longitude, then you have to give space in between main degree and second, etc. So that is an important feature, important step which you need to remember. Okay, so as you can see here, I have mentioned in the slide also that use spacebar in the keyboard to separate the degree value from minutes and seconds. So as I am saying, 74 degree 14 minutes and 10 seconds, it has to be 74 space 14 space 10. That way we would be proceeding. And when you will OK it, it will come like this, and that way 4 corners would be taken. So 4 GCPs would appear here. Now there is another interesting aspect which you should be remembering and make it very clear. Now you see how the computer would learn as to how it has to orient the map into the digital format, georeferencing of digital in digital format. So there are some statistics which goes behind the scene in the system. So for that matter, you need to select either polynomial 1 or 2, whatever it is. We would be selecting only 4 GCPs. So for that matter, we require minimum of 3 plus 1. So 4 coordinates we would be using. So there within the CRS, we would be selecting the polynomial 1 as transformation technique. Okay, so that also you need to remember that this year. Now, when we select polynomial 2, then you have to take at least of 7 plus 1, 8 GCPs. So it depends on you. If you have, if you want to be very precise, you can take 8 also. But in this exercise, we would be only doing 4 with the help of 4 GCPs. So there we need to take only one polynomial 1 as transformation of georeferencing. So this would be happening. Now what happens when you have completed the GCPs, you have to select on this transformation setting, which is appearing in the menu bar here as my cursor is moving, and it will appear like this. So this transformation setting you need to click, and here that point which I am highlighting, polynomial 1, it has to be done over here, and then you have to select OK. So when you would select OK, it would appear like this. Where this output raster is to be saved, that you have to check, and all the settings remain as OK. You just OK it, and when you will OK, that way it will be georeferenced. Then it may also ask as what would be the name of this map which you have georeferenced. It will also ask as whether you want to save the GCP point or not. You should save it in the folder, whatever folder you want to save into it, that name you have to give. So these are the basic steps for georeferencing a map. There is one more important thing which I would like to highlight. There is on the GCP table, on the right side, there is residual pixels also. And here you would see that it is 0.1, 0.2, 0.2, 0. These are all acceptable. That means the error is well under control. But if the residual pixels are greater than 1, then you need to do it again. Some of the GCPs you need to delete it. You can delete it from here, clicking on it, and otherwise you should do it all again. Or those residuals which are higher, that should be deleted and a new GCP point should be added. There might be some error while you are clicking on the point, or there might be situation where the some error during the input or in the map might be existing, so that you need to rectify. The residual value should not be more than 1. It should be in decimal, as it is appearing 0.1 and 0.23. It is acceptable. So that also you need to taken care of it. The mean error is displayed here, 0.4. It's acceptable. But if it is on the higher side, then you need to recheck. There is some error in georeferencing process. You need to look into it. You recall one more aspect when we discussed in the theoretical part. You know that we said that during encoding there is possibility of error to be coming into our database. That is one reason for it. You should be a little careful of it. And that way, then you have to click here, this button within the georeferencer. There would be one button like this. When you click this start georeferencing, it will go here and gradually it will be georeferenced, and then output. You can also notice that the output file would be loaded in QGIS canvas like this, and when you would be scrolling and moving your cursor here, the coordinates would be changing. That will give you an idea, that will give you the confirmation of your georeferencing process. So that way you can do georeferencing. And you need to save the GCP, as I am saying, and this you can recall again if you want to do it. So this is what the georeferencing of image of India map.